Hi everyone. In this lecture we'll study exception handling. Alright. So before studying exception handling, we should know what the exception is. Alright. So it's like problem solving. If we don't know the problems, how can we solve them, right? If we don't know the exceptions, how can we handle those? So exceptions are basically the runtime anomalies and abnormal conditions that happen during the runtime. For example, the most famous example, divide by zero. If you're writing a program that is doing some division, right, and the denominator suddenly becomes zero, right? So basically that is not allowed in mathematics. Divide by zero is basically undefined. So when the computer processes that, it is a runtime error and the program execution is halted, right? So we don't want that, because this is a small program, right? In this case it's a small program, that it's a division program, but there are, for example, let's expand the situation, that let's expand the scale of the situation. The situation is like you have a really huge software, right, whose code has millions of lines of code, and it is running on some server, right? So, and that software is being used by millions of people, and or it is used by some business companies, and it's generating billions of dollars of revenue for the company that is hosting the software, right? So at any point of time, the company cannot afford to stop that software. Imagine if the Google stops working for 1 second, for 1 minute, right? It will cause billions of dollars of revenue loss, if not trillions, right? So that's the importance of exception handling, right? Exception, because at any point of time, if you have a really huge software, then small runtime anomalies will come. So because of those small changes, do you want the software to be stopped and cause the revenue loss? Definitely not. What you want is, you want to take the account of those errors, right? And when those error comes, you want to maintain a record of those errors, means the line number from which the error comes, or whatever it is, the timing, and the execution of the program should be continued. That's what you want, and that's what the exception handling is for, right? So exception handling is a process of exception handling exceptions. As simple as that. For the sake of definition, exception handling is a process of handling unexpected runtime errors, or maybe expected runtime errors, right? So basically we want to handle the runtime issues at the runtime only, right? We have already discussed exception handling in my life also. Since I am a software developer, I'm working on those software which are, I can't reveal the exact details, but currently I'm working on many softwares which are basically used by B2B companies, and they are generating billions of dollars of revenue, and those are huge systems, and without exception handling, I can't imagine my day, right? I cannot debug even if there is no exception handling. I guess you are understanding the magnitude of this situation. All right. So exception handling in C++, right? In multiple programming languages, there are different means syntaxes. There are different ways to handle the exceptions. In C++, we have three keywords, that is try, number one is throw, number two is throw, and number three is catch. Try is the block of code where you actually write your original code, right? In try block, right? We have a try keyword, and after that we have curly braces, and in those curly braces, like this, we write our original code. That means that code is success. Maybe there are, if the error comes, right, we use the throw keyword, right? For example, we know, maybe, for example, if this error comes, right, if the denominator is zero, we won't divide it. Exception is thrown immediately, and corresponding to that exception, there is some block of code, right? In the catch, we use catch keyword, and in this catch keyword there is exception name, right? And corresponding to that throw, corresponding to this exception, the catch block is mapped and this code is executed, right? So that's how the exception handling works. So let's write a program. This is our IO stream. Namespace standard. Let me increase the size right here. Now for example, let's say we have numerator is any number, right? Let's say we have numerator and we have denominator. Let's say we want numerator, right? And we have denominator. We are taking inputs, right? And what we are doing is we are checking that if DAM is equal to 0. For example, if the denominator is 0, which is undefined and which cause the runtime error, right? So we will handle it, right? How to handle it? We'll simply throw 0, right? And first of all, in this we will use try block, because this is the code we want to execute, right? This is the ideal condition, and if there is throw, then definitely a catch will be used, and here int num, right? Now if number is equal to 0, divided by 0. All right, so if this situation is there, then exception is thrown, otherwise the result will be printed, right? Now this is our numerator and this is our denominator. See, divide by 0 exception is thrown, right? So now let's say 6 by 2, the result is 3, right? So this is exception handling in C++, right? Now in this case we know, right? We definitely know that there is a possible scenario where denominator is 0. Now there can be hell lot of other scenarios, and it's very difficult to write catch block for all of those, right? So can't we have a generic catch block where it will handle all the exceptions? Sure we can, right? Instead of putting any argument, we just put 3 dots instead of any string here. For example, instead of throw, there are n number of 2 scenarios where their denominator is 0, and instead of this number we have the user is stupid, and the user is providing a string, right? By the way, user is never stupid anyway. So if the user is stupid, if the user enters string instead of number, then we have to handle that case also, right? So instead of putting multiple catch blocks, right, for this case, for this case, for this case, we just need the catch block with 3 dots, and after that we can write a generic exception here, right? Not able to divide. Let's 3 by 0, not able to divide. It's as simple as that. I don't know if you're able to see that. If you're able to understand it, let me explain again. Instead of catch block, now let's say we want another condition, right? If the denominator should not be less than 0, right? I hope you have if else and all the things, right? Then throw anything, right? Anything. We don't have to use separate catch block for that. We will just use this one, this and minus this. Not able to divide. Now we don't know what is the user don't know what is the issue. Is the negative a issue or the zero? Because with three dots we are not able to provide the enough input. Here if it was in, right, if you provide a number, then in this case we could provide separate catch block for string, separate catch block for integer, and for integer we could say if the integer is 0, then there is a 0 error. If there is a string and it's written something negative, right, then we could write because of negative we are not able to divide. Now the user doesn't know at all what the issue is and the user is completely lost, right? So definitely it's a good approach, but definitely not the best approach. Maybe it's a trade-off, right? It's up to the developer if the developer wants it or not. This is the basic of exception handling, pretty much simple, right? The try block, which contains all the code, the throw code, which invokes the exception using, and the catch block, which using the catch block we handle that exception and the execution continues. Yeah, so that's all the thing, and this is all the exception handling. Nothing, not a big deal, right? The catch block is a block of code that allows you to provide an action code to the program so that if any random exception occurs, program has some steps to recover it and the program execution is not halted, right? So this is the catch block, right? We are providing an argument here instead of argument. If you provide three dots here, then definitely our job, it reduces our job, right? But we also have a disadvantage that we can't print a particular exception, right? For a particular debugging purpose we have to write a generic exception, and that won't help in debugging, right? So that's the exception handling basics, right? So if you know these kind of things you should know, right? What we can do is we can take a txt file, right? We can write all the exceptions there and store that in some folder so that when the developer uses you refer to that folder file, txt file, for the debug purposes, and the developer can see what the hell happened in his program, what went wrong, and it will able to help the developer ultimately. But this situation with three dots, it is not going to help the developer. That's why it's not that much popular, right? So it's up to the developer. If the program is small, then it can use three dots, right? Why not? But if the program is huge, with huge I mean humongous, in the extreme case it's humongous, billions of lines of code, you're working in Google and you don't use, and you're using this, then it will be a big headache to you, right? So that's all for today. If you have any doubts, you can ask, right? Ask your peers, help your peers, because it will help them and help you, because teaching is learning twice, right? So I am also learning, right? So that's all for today. If you have any doubts, you can ask us. We'll meet in the next lecture. Till then, see ya.